The most basic economic problem is problem of scarcity. We have not only scarce resources in terms of money, but also in terms of our time and effort we can spare to do everything at the same time. This leads to problem of choice. And every decision we have to make involves trade-off alternatives that we must give up when we make a choice. Let us understand this through an example. Let's say a freelance website developer decides to paint the flat he lives in on his own instead of hiring a professional painter who would have costed him $1,000. He will need 2 weeks doing it. The website work would have given him $3,000. Now you will say that monetarily he is making a loss of $2,000. However, we should understand that humans look for non-monetary subjective gains for their actions known as psychic profit. Maybe the person here likes to do physical work at home, or he gets certain level of satisfaction by doing creative work. In this case, taking the website development work is an alternative he decides to let go. Similarly, let us say that after graduation, you have a choice of either pursuing post-graduation or taking up a job. Each decision could have different benefits for you. There is a trade-off. The alternative you let go becomes your opportunity cost. Remember, opportunity cost is basically the road not taken. Also, you need to keep in mind that cost is not always equal to money in economics. In economics, cost includes explicit costs as well as implicit costs. The psychic profit or loss is also a part of the cost. In economics, the model used to illustrate the concept of opportunity cost is called production possibility curve or frontier. To understand this model, we will make few assumptions. Let us say that we have an economy which has limited resources and they can produce two things, robots and cars. We also assume that there should not be any wastage of resources and technology remains constant. If we look at the table, it shows all the combinations of the two goods that we can produce with given resources. If we produce 0 robot, we can produce 15 cars. And if we produce 0 car, then we can produce 5 robots. If we plot these points on a graph, you will get the figure on the right side. The curve AF is called the PPC curve. The PPC curve shows all the possible combinations of robots and cars that can be produced using given resources and given technology. If you need to practice how to plot this graph, you can check out my video on how to draw graphs, the link to which I will share in the description of the video. Another important concept you need to understand is the marginal opportunity cost. Marginal opportunity cost for a commodity is the amount of a good to be given up in order to get an additional unit of another good. In our example of robots and cars, how many units of cars an economy will have to lose in order to produce one additional unit of a robot? One of the way to calculate MOC is this formula. By using the formula of taking change in loss of a commodity divided by change in gain of another commodity, in our case we are losing cars and we are gaining robots, we can calculate for each new unit of robot what is the opportunity cost. As you can see in this table, when we are moving from point A to B, we are losing one car and gaining one robot. We can calculate this by using the same formula. When we are moving from B to C, we are losing 2 cars to gain 1 robot. This way we can calculate opportunity cost for the production of 1 more unit of robot. The same concept we can understand through a graph. Here you can see that when we need to move from 0 to 1, when we want to produce 1 robot, we have to let go 1 unit of car from 15 to 14. But when we want to achieve second unit of robot, when we want to produce another unit of robot, we have to let go 2 cars. Therefore, for every additional unit of robot, you have to let go more and more cars. You are losing more and more units of cars. This is the case of increasing marginal opportunity cost. There is one thing you need to observe very carefully here. There is a difference between opportunity cost and marginal opportunity cost. Remember, marginal means additional unit. If we were to move from point A to D, then we are not looking at marginal. We are just looking at opportunity cost total. So we are looking at opportunity cost when we are moving from A to D. The opportunity cost is we are losing how many cars? A to D we are losing 6 cars. This is our opportunity cost, but this is not the marginal cost. From B to E when we are moving, we are losing 9 cars. The opportunity cost would be 9 cars. This is not equal to marginal opportunity cost. There are 3 possible shapes of production possibility curves. Usually we find a PPC curve which is concave to the origin, as we have seen in our example of robots and cars. If you notice carefully, the shape is concave. Concave shape shows increasing opportunity cost. It could be that all factors of production may not be equally efficient in production of both these goods. If we take away labor or capital from the production of cars towards the production of robots, the labor may not be efficient enough to produce robots. As more employees move from cars to robot production, efficiency decreases and the company produces lesser robots in the time it would take to produce additional cars. It may also be necessary for the company maybe to retool their manufacturing line to make robots, increasing production costs and further lowering the returns on robots so that the shift is less financially attractive. In case of straight line PPC, the inference is that the resources are equally efficient in the production of two goods. For example, in a bakery, it may not matter if the baker has to bake cookies or cakes. The resources may almost be the same even in terms of skill and expertise. In case of convex shape, the inference is that each time we have to let go lesser units in order to produce same unit of another good. This could be due to increased labor efficiency or economies of scale. The labor may be more efficient in the production of wallets than belts, or the company or economy is able to achieve reduced average cost of production due to large order of wallets than belts. So these are the 3 possible different shapes of PPC curves. The PPC graph is very important, and the best part is that it shows all the key concepts that we have been learning so far. It can be used to show scarcity, trade-offs, opportunity cost, and efficiency. The idea of scarcity can be shown by any point outside the curve, which implies that we cannot produce anywhere beyond the curve. Here in our example, it's at point M. So the curve or the frontier shows that there are limited resources. Anything beyond this curve is unattainable. Any point inside the curve shows inefficiency, which means we are not using our resources to the fullest. Like at point J here, we can still produce more units of both the goods. Any point on the curve like A, B, C, etc. shows that there is a full and efficient use of resources for any combination of robots and cars being produced. The curve itself shows efficiency. We can also show a trade-off. In case we want to produce the combination B, then it means we might have to let go production of a car in order to produce one more robot. Or if we move from B to E, then we have to let go of more cars to produce more units of robots. The PPC curve can shift as well, which I will discuss separately in my next video. You can find a blog related to opportunity cost on my website www.economydz.com. The direct link to this blog post will be shared in the description box below. If you have any specific topics you would like me to make videos about or offer any other suggestions, you can share them in the comment section below. And don't forget to subscribe, like and share my videos.